Hello friends, welcome back to our channel. So today we'll see one more concept in algorithms, that is merge sort using divide and conquer method. So the sorting is arranging the elements either in ascending order or descending order. So by default we'll go with the ascending order, right? That means a lower to higher. So one type of that process is a merge sort. So by using this merge sort also we can sort the elements, and this will follow the divide and conquer strategy, right? So we know about the divide and conquer. So it will be having some three stages. One is dividing the problem into subproblems, and second one is a conquer. So that means providing the solution or finding the solution for each subproblem recursively, and the last one will be the combine. So we need to combine the solutions of all the subproblems to get the main solution. So the same process will be applied for this particular merge sort, right? So here in this session we'll see an example, so that we'll be getting an idea how the merge sort will be implemented, and then we'll go with the algorithm or a pseudocode. So based upon the procedure which we have known in this example, so we'll write the algorithm and we'll check, and finally we'll see what is the time complexity, the worst case time complexity of a merge sort, right? So we'll see one by one. So first let us start with the example. So let us take a few elements, unordered elements, and then we're going to use the divide and conquer method. So 50, 60, 10, 70, 30 and 40. So let us take these elements. Now we know that these elements are not in a sorted order. So we have to arrange them in the sorted order. So initially we'll write the index values 0, 1, 2, 3, 4 and 5, and we know, so this is the low. We will represent this one as a low and this one as a high. This one as a high. So the first step is divide. So we need to divide the complete problem into subproblems. So formula. So by which formula or by which criteria we need to divide the complete elements into two halves. So that is based upon the middle value. So mid value. So we need to calculate the mid. So mid is equal to, so low plus high divided by 2. So we need to consider only the integral part. So that will be low plus high by 2. That means 0 plus high 5 divided by 2. So which is 5 divided by 2, which is 2.5, and we need to consider only integer. So that will be 2. So mid is 2. Mid value is 2. So here I write mid is equal to 2. Now what happens? We need to divide the complete problem into two halves based upon this mid. Okay. So what's the mid value? 2. So this is a mid. Okay. So where we have to divide? So one part is from low to mid, and the second part is from mid plus 1 to high. So based upon this one, we need to divide the complete elements into two halves. So here we will write, so 50, 60, 10, 70, 30, 40. So this is one part, and this will be the another part. So again we need to divide the elements further based upon the middle. So we have to solve these two parts individually and recursively. So what happens here? This is 0, 1 and 2, and we need to calculate the mid. Mid is equal to 0 plus 2 by 2. 0 plus 2 by 2. So which will be 1. Which will be 1, right? So we need to divide this one into two halves. So 50 and 60, that means low and mid plus 1 and mid plus 1, right? So here also we need to apply the same process. So mid is equal to 0 plus 1, sorry, 0 plus 2 by 2, so which is 1, right? So this is 1, 2. So now here also the same process. It was divided into 70 and 30 and again 40. So two parts. So complete data is divided into two parts and each part is again further divided into two parts. And similarly here also it is 0, 1 and it is 0, 0, 1 and it is 0. So here again we need to divide. So mid is equal to 0 plus 1 by 2 which is equal to 0. So we need to consider 50, we need to consider 60 and here is only one part, that is 10, and here also the same. So mid is equal to 0 plus 1 by 2 because this is a L, this is a high, low and high, low and high. So low plus high by 2. So here also we need to use the same thing. So 70, 30, 40. So right, this is the process. This is the process. Right? This is a process. Now we got complete elements here. Now what we have to do? We have to compare each and every element and we need to arrange the elements in a sorted order. What we have to do? So we need to compare this 50 and 60. Okay. So 50 and 60, obviously both are in the same, right? And this is 10. And apply the same process here also. So 30 is greater than 70, so 30 is less than 70. So we can see 30 and 70 both comes in the same thing, and now it will be the 40. See what we have to do. So let us assume this one as I and this one as J, and this one as I, this one as J. So we need to compare I and J. Here also you can see this is I and this is J. This is I and this is J. So we need to compare the I value and J value, and if the element whichever it is lower, that should be loaded in the new array. So this is the new array. You can observe this is a new array, right? So compare 50 and 10. Which is the highest? So which is the lowest? 10. So obviously 10 will be placed here first, and this value will be incremented. That means it will be moved to the next one, next element. And here also now there is no element in J. If in such cases whatever the elements remaining in this particular subarray, so that will be loaded into the new array. So 50 and 60. See, 50 and 60. So after combining this one, so we got these elements. Similarly here also, let us assume the new array. See, 30 is compared with 40. So which is lower? 30. So 30 will be stored in new array 30, and immediately I value will be incremented. So now I value is pointing towards 70. Again repeat the same process. 70 and 40. So 40 is the lower. So now place 40 here and J is incremented. So there is no other value in this particular array. So whatever the elements remaining in this subarray, that will be loaded into the new one. So 70 will be copied here. So you can observe after every step we are getting the elements in a sorted order. So here you can see 10, 50, 60. These elements are in sorted order. 30, 40, 70. These elements are in sorted order. Now what we have to do? So we have to combine these two arrays. So after first division you can see 50, 60, 10, and now it is 10, 50, 60. After division 70, 30, 40, here you can see 30, 40, 70. So we have to compare each and every element of both the arrays, and we have to create a new array, and if whatever the element which is lesser, that element should be copied into the new array, and that index should be incremented towards next one. So if there is no other element in the array, then automatically whatever the elements remained in the next array or the another array should be copied into this one. Now, if you are still having any doubts, so let us solve this one so that you will be understanding, right? So here we are having 3 elements and here we are having 3 elements. Now we will solve this one. So I will erase this one. Right. So let us consider 10, 50, 60. So 3 elements, and here also we are having 3 elements, 30, 40 and 70. See, now what we have to do, so we have to compare each and every element, right? See, so let us consider this as I, this as J. Okay, this as I and this as J. Now, what we have to do, so we have to compare 10 and 30. We have to compare 10 and 30. So, this is a new array. Okay, this is a new array. So, 10 and 30. So, which one is less? 10 is less. So, obviously 10 will be stored in the new array. So, 10 will be stored in new array and I will be incremented this to the next one. Because 10 is already here, right? So I will be incremented to the next one. J remains same. Okay, J remains same. Now 50 is compared with 30. So which one is low? 30. So 30 will be copied into the new array. Right? 30 will be copied to the new array. Now J will be incremented. J will be incremented. Again compare 50 and 40. Which one is low? 40. So 40 will be stored here and again J will be incremented towards here. And again 50 and 70. So 50 is less. So 50 will be copied here and I will be incremented towards here. So 60 and 70. 60 is less. So 60 will be copied here and I will be incremented and there is no element in the array. So it goes beyond the index. So then immediately what we have to do? So we have to go with the next another array and whatever the elements remaining in that array will be directly copied to the new array. So only one element is there. So already 10 we have copied, then 30 is copied, then 40 is copied, 50 is copied, 60 is copied. So only one element is remains here. So we will simply write 70 in this place. Okay. Now we have taken the elements here, 6 elements, 50, 60, 10, 70, 30, 40, and now we are getting the elements in a sorted order. So 10, 30, 40, 50, 60 and 70, right? So here we have done the division. So where we have divided the complete problem into 2 halves based on middle value and then conquer. So recursively we are keep on solving by comparisons and then combine. So we are merging or combining all the different subproblems so that we are getting the final solution, right? So hope you understood this one. So based upon this explanation we will write the algorithm, right? Yes. So what we have to do? We have to divide the complete elements into 2 different halves. So let us write merge sort. Okay, merge sort. So here we can write yes, one is array, another one is low, and another one is high. Okay, now what we have to do? So if low is equal to high, that means only one element, right? There is no comparison. Okay, there is no comparison. Nothing can be done. So we can return a direct elements. Return element. Okay, so only one element means that will be in the sorted order. Else, what we have to do? We have to divide. So recursive call. Again, apply the merge sort. And what we have to divide? so array of elements, and then low to mid, and then again we have to divide merge sort A mid plus 1 to high. So once the division has been completed, then we have to combine. So that we call it as merge. So don't get confused. Merge sort is different, merge is different. Merge function. So here we will write low, high, mid. Okay. So what we are doing? So first we are checking whether it contains a multiple elements or a single element. If it is single element, simply we can return the element. And if it is a multiple elements, then we have to divide the multiple elements into two parts. One is from low to mid and mid plus 1 to high. And once it was completed recursively, then we have to start merging both, all the solutions, right? So we'll write the merge part here. Merge three things, that is low, high, mid. Okay, also we can take array because we need to pass the array, so also we can write array. Four parameters, array of elements, low, mid and high. Now, okay, so what we have to do? So we have to check, so we have to initialize first. Initialize. Let us initialize I is equal to low and j is equal to what we are doing. So we are taking two parts, and here I am writing I and here I am writing j. So right, so I is a low, j will be the first element of the second array, so which is nothing but mid plus 1. Hope you understood, right? So j will be the first element of second array, I will be the first element of first array, so automatically I will be low, that is 0, and j will be mid plus 1. And we need to continue this process until the two conditions satisfies, I less than or equal to low and j less than or equal to high. So here, here it is not low, it is mid, because so until I reaches mid and here until j reaches high, because this position is mid and this position is high. So we are keep on comparing each and every element and we are incrementing the I value and j value, and this process should be repeated until I reaches to mid or j reaches to high. So I less than or equal to mid and j less than or equal to high, we have to repeat it. What we are doing, we are comparing this element and this element. So what is the element? So comparison means a condition, right? So if a of I less than a of j, what we are doing? So if a is less than, this element is less than this element, what we are doing? We are copying this element to a new array. Let us consider here a new array. Some b is equal to, okay, so let us take index value 0. B is equal to index value 0 and b is some array of multiple size. Let us take some 10 array. Okay, so what we have to do? So b of I plus plus, so here we have taken b is an array and let us take the index value as 0. So b of k plus plus is equal to a of I plus plus. So what happens? This is the postfix. Okay, postfix. First it will be copied and then automatically it will be incremented. And you can also write the same thing in this way. B of k is equal to a of I, and you have to increment the I value. So once you copied this element into this one, we have to increment the I value, right? So we have incremented the I value. And simply you can write else what happens? If it is false, that implies a of j is less than a of I. So A of j should be copied here. So this element should be copied here. So B of k is equal to A of j, and j should be incremented. J should be incremented. So j should be incremented to the next. And both the cases we have to increment the k plus plus, because once the element is inserted here, the k should be incremented so that the k points towards here. So k should be incremented, right? So once all this done, then if it reaches to here, what happens? We have to move all the elements of first array to the new array, or all the elements of second array to the new array. So for that we can simply write a loops. So while, simply write it I less than or equal to mid. Okay, I less than or equal to mid. Simply write down B of k is equal to A of I, and simply write one more thing, j is equal to j less than or equal to mid. B of k is equal to A of j. See, this will be happened. Okay, this will be happened. Sorry, here you have to close, and this is outside the loop. Outside the loop. Okay, so what we are doing? We are comparing the elements, and we are selecting the lowest element, and that element will be copied to the first position here, and then we are incrementing the I value. So the same thing happens here. This code is the similar, right? So once I reaches to mid, what happens? So we need to check whether the elements are remaining in the either of the array. So if they are remaining, so we need to copy all the elements to new array. Okay, and here also we need to increment the k value and the I value. So in both the cases, I value and k value will be incremented. So simply we can write it as k plus plus I plus plus. So because of this post increment, first the value will be copied, and then the this one will be incremented. Okay, so this is a algorithm or a pseudocode, so whatever it may be. So based upon our explanation on an example, right? So hope you understood this one. Now we'll move on to the time complexity. So what is the time complexity of this merge sort, right? So we'll see what is the time complexity. So what we are doing, so time complexity of 1, if it is one element, that will be 1, right? So T of n is equal to, so first the problem is divided into two parts, and we are solving both the parts. So T of n by 2 plus T of n by 2, so two halves, and we are considering both the things because we are solving both the parts. Okay, whereas coming to the binary search, so we are moving on with only one part, right? So that's why we have not included both the parts, right? But here, so we need to solve both the arrays. We are dividing the problem into different parts, and we have to solve all the parts. So we have to consider this one, and plus what we are doing? We are doing n comparisons. So how many elements are there? Then that many comparisons we are doing. So we are comparing each and every element, and we are performing the operations. So plus n. So this we can write it as 2t of n by 2 plus n. Okay. Then coming to the relation. So if n is equal to n by 2, right? Then t of n by 2 is equal to 2 into, okay, T of n by 2, right? So 2t of n by 2 divided by 2 plus n plus n. So it will be 4t of n by 4 plus, so what happens here? So this is n by 2, right? So 2 into n by 2, it will be n plus n. So which gives a 4t of n by 4 plus 2n. Okay. So the same thing, right? Plus n means here we are in the place of n we are dividing the n by 2. So once again in the further process, right? So first there are some 6 elements, then 3 elements. Again 3 is divided into 2 parts. Further division, so we can write 4 into 2t of n by 2 divided by 4 plus, okay, n by 4 plus 2n. So it will be 8t n by 8 plus n plus 2n, which will be 8t n by 8 plus 3n. So this will be keeps on moving, right? This will be keeps on going. So that can be written as 2 cube. 8 can be written as 2 cube t of n by 2 cube plus 3n. So this can be written as t of n is equal to 2 power k t of n by 2 power k plus k into n. So this process will be repeated. So what is the stop condition here? So when we are going to stop the division, right? So here I'll write stop condition. So this is the most important, right, while calculating the time complexity. So whenever it will be, so we are keep on dividing the problem and we'll stop when it becomes one element. When it becomes one element. So obviously we can write it as k is equal, n is equal to 2 power k and k is equal to log n base 2. So this is the stop condition. Now you can know, so k value you know and 2 power k value you know. So substitute the same thing here. So 2 power k, which is nothing but n into t of, okay, n into t of n, it's a 2 power k, or simply we can write n by n plus, what is the value of k? Log n. So log n base 2 into n. So this will be n into t of 1 plus n into log n base 2. And this becomes 1. So that will be n plus n log n base 2. And obviously you can see the highest degree, that is n into log n base 2. So the time complexity, the worst case or average case time complexity for the method will be n into log n. That means we have to write by using the asymptotic notation. So big O of n log n. So this is the time complexity for method. This will be the time complexity of method, right? So hope you understood the time complexity for this method. So whatever the process we have studied right now, so we have seen one example, and after knowing the example we have written the pseudocode and then we have calculated the time complexity for this method, right? So hope you enjoyed the session. So if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.